All right. Hi. So today we're going to be talking about color modes, blend modes, and a super brief introduction to arrays, right? So let's start kind of where we left off last time. So we talked about how we can split up our canvas into several sections, and then we can sort of do things repeatedly, but maybe with small variations. So I want to start with a couple of ideas at that starting point, and then we'll kind of progress from there. So idea number one, there's more than one way of doing things, right? So this is kind of fundamental to all the programming and a lot of other creative endeavors. Um, there's more than one way of doing things, and you can try it this way, you can try it the other way, right? It's almost like the idea is that if you wanted to get 50, you can divide 100 by 2, or you can multiply it times 0.5. The result is the same, right? The expression is equivalent, but it's different ways of achieving the same outcome, right? So where it's going to come handy is how I'm going to be splitting the uh, canvas into rows and columns. Okay, so we are not going to be using our draw function, so we might as well get rid of that. And then, so in the setup function, let's set our canvas to be 800 by 600, so like nice landscape mode. And I'm going to start by just introducing a basic background, so maybe something like background of 125, something like this. And then let's look at how we can start splitting things up. So last time we tried to sort of count the number of pixels between each column. Now I'm just going to keep track of the number of columns. If you remember, last time we kind of had the need for that, right? And we had to kind of like introduce this idea of an iterator that we just did a plus plus to, or like we added a single digit every time to that iterator. This time I'm gonna try and keep track of what number column I'm on, right? So, and then same thing for the row. So if I'm going to be counting my columns, right? So let's do our for loop, right? So for let x, and I'm gonna start with 0. It's gonna come very handy when we start dealing with arrays, right? I'll point that out, but the core idea is that arrays in the vast majority of programming languages always start counting at 0, right? So the first element is 0, the second element is number 1, the third element is number 2, and so on and so forth. So this is almost habitual, where we start counting things starting from 0, right? From 0 to 9, and then and so on, right? So we're going to start with our x equal to 0. In this case, our x is the number of the column that we're counting, and then the y is going to be the number of the row, right? You just as well can use a different letter or different name for a variable. It's up to you, but I'm going to stick with x and y because it kind of nicely denotes that x is the horizontal count and y is the vertical count. All right, so we're going to start at 0, and then we are going to go through a certain number of columns, right? So how do we, so I'm going to just introduce a hypothetical variable. I'm going to say for as long as x is the less than a certain number of columns like this, right? So I don't know what that number is, but we'll get to that point. And so we're going to do x. Remember that plus plus thing, right? X plus 1. So itself plus 1. So we're going to start with x at 0. And then if x is less than the number of columns, which we'll calculate right now, let's say we have 10 columns. So x is 0, 0 less than 10? Yeah, it's less than 10. Then let's add 1 to 0. So the first time it's going to be 0. Then for the next loop, we're going to come back and we're going to be like, all right, 0 less than 10, add 1 to it. Moving on, right? 1, then let's go for the next iteration of the loop. Is 1 less than 10? Yeah, it's less than 10. Let's add 1 to it, and so on. So it's going to become 2, and we'll run through the loop again. Okay, so that's going to be our outer for loop. Now let's figure out how many columns I'm going to have. So I'm going to start doing circles again, right? So last time we did triangles and circles and different shapes. I'm just going to stick to something super simple. It's going to be a circle. So each circle is obviously going to have a diameter. And I'm going to start with my, let's say, C diameter. Or let's just call it diameter. All right, so circle diameter, right? And this is going to be, we can start with something simple. Let's do 80, right? So 800 divided by 80 is 10. So we're going to have 10 columns. And then, so how do we figure out the fact that we need 10 columns, right? So each circle is 80. We have 800 pixels, then 800 divided by 80, we're going to have 10, right? So I'm going to say let number of columns equal to, right? And then width, right? Because we know the width of our canvas because we already declared it. So it should be available right here. So width divided by diameter. Okay, so that's going to be our number of columns, right? And we can do like a quick test and say, let's just draw a circle. And, well, let's just draw whatever, just simple white circles. Just draw a circle, right? And then we're going to say that our circle is going to be located in the center of the column. So that's going to get a little bit tricky. How do we figure out what the center of the column is, right? So first we need to find out our x, right? So times diameter, right? And then y, let's have it like some basic number, like let's do height divided by 2. And then our size of the circle is going to be obviously diameter, right? So let's just talk through this a little bit. So we said that our x position is going to be x times diameter. Height is going to be the y value, the y position is going to be the height divided by 2, and then diameter is going to be diameter. So the reason why I'm doing this is that I want my circle to move on that many columns, as many as fits into its, as many as, like, so that many diameters as the number of the columns I'm on, right? So if I'm on column number 5, that means I'm going to have to shift 5 diameters and then draw the circle, right? So let's just try it out. Let's see what happens. It's not going to be exactly what we're looking for, but it's going to get us somewhere, right? Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 circles as we expected. It's almost there, like I said. So the reason is that the diameter gets us from one center point to the next center point. So instead of drawing the circle in the middle of the column, right, we're kind of drawing a circle at the beginning of the column. So we have kind of like 2 half circles within one column, then 2 half circles within the next column, and so on. So in order to do that, we need to kind of shift all of our circles, and it's very obvious like how we need to shift them by half a diameter. So if the center point of the circle right now is at line 0, right, because clearly on the first iteration of our for loop, x is equal to 0. 0 times 80 is 0, right? So the center of my circle is going to be at the 0 point on the x-axis, right? So here it is, the 0 point on the x-axis, and here it is half the height on the y-axis, right? So I'm drawing my first circle at that 0 point. So if I wanted to shift it by half of the column, right, and now each one of the column is the size of the diameter, I just need to move it by half of the diameter. So if you remember, if our 0 point is here and our width is here, that means that in order to shift something to the right, we need to add things, right, moving away from 0. in the positive direction. So the positive direction is going to be this way, and the negative direction is going to be that way. And it's kind of an important concept that's going to become very useful later. So let's add half a diameter to it. So plus diameter, and let's express our half differently this time, times 0.5, right? So half of its diameter. So we can bracket those things in order to make them a little bit more obvious. So like this is our half a diameter, right? We don't have to. Obviously, all the order of arithmetic operations still applies, right? So multiplication before addition, but putting it in the parentheses makes it a little bit more readable. So that's one of the reasons why we might want to do that. So if I run it like this, ooh, I have an error. So it says diameter, typical, right? Like misspelling. Another very, very typical mistake is misspelling something. The rule of thumb, how to avoid misspelling, is just copy and paste the names of your variables, right? But the console in P5JS editor has some very, very useful hints, right? That would give you kind of an idea of where the error might be. So diameter is not defined, so just start checking for what the error says and try to follow the lead from there. All right, so let's run it like this. So okay, so we shifted it by half a diameter, and we're good to go then. So now if I wanted to populate the entire area by circles, right, I would obviously have to also take this circle creating line and put it inside, like make many circles within one column, right? So if you remember how we did it last time, so one way to just kind of visually demonstrate it, this is our circle creating line. I'm gonna cut it out and sort of like put it here, right? That's gonna be the thing that's gonna make circles for us. And so I'm gonna have certain number of columns, but I'm also gonna have certain number of rows, right? And for each column, I'm gonna populate a bunch of rows, and then another bunch of rows, and then another bunch of rows, and so on. So I'm gonna do, for each one of the columns, I'm gonna run the internal loop for the rows. So I'm going to say let y equal 0, y less than, and again, we're going to introduce number of rows, and then y plus plus. So 0, then 1, then 2, then however many, right? So let's introduce our let number of rows. And honestly, like, you don't have to do it here. You don't have to do it for every single column. You don't have to recalculate it. The only reason why I'm leaving it here is because it's going to be easier for you to, since this columns relates to this loop, this rows relates to this loop. So just kind of for readability, it's going to take a minuscule more computing power in order to calculate those digits for every row inside the column. We can spare it just so that our code is a little bit more readable and a little bit more clear. So all right, so number of rows is naturally going to be height divided by the diameter, right? So again, this is JavaScript. We don't really need semicolons. I don't know why I'm putting them here. And then, so what we're saying is for every column, create a bunch of rows. And for inside every row now, create a bunch of circles. So the circle creating line can come out and be placed over here. So if I do it this way, oh yeah, well, I can't just use middle of the screen anymore. I just have to use, in this case, y times diameter, right? I think I spelled it correctly. And again, if I just do it like this, it's going to be off on the y-axis, right? So we're going to say plus, and in this case, diameter, see, misspelling it, diameter times 0.5, again, shifted by half a diameter. All right, so here's an interesting thing. While 80 fits neatly into 800, it doesn't fit quite neatly into 600, right? So half of the circle is actually off. So even though we started like neatly, our first or 0th circle is fits perfectly into its own cell, we have like this half a space on the bottom. And this is actually not a super uncommon situation, right? Like for the vast majority of diameters, um, we're going to encounter this, right? So what if I switch it to something that actually doesn't fit in either? So let's say 90, right? 90 is an odd number for both 800 and 600. So it's just off, right? So we start populating it neatly, but we're not continuing that pattern, right? So not a bad problem to encounter, simply because it opens up a certain way of thinking about space and about the geometry of space and how you might want to start approaching patterns within space. So let's look at how we can potentially work around this, right? So what I need to do is say something like, I want as many circles on the screen, as many columns and as many rows as fully fit on it, right? But if I have a fraction, I don't want that fraction, right? So let's say for the columns, one way I can start thinking about it, let's console.log our number, right? We'll columns, right? This is going to be the number of columns. I think I misspelled something again, so I'm not even going to bother. Let's paste this like this. And if I run it, it's 8.8888889, right? So there's a fraction after it. So what I need to say is like whatever fraction remains, drop it. Drop that fraction, round off to the lowest integer from this point, right? And so there are some mathematical functions included in P5 that will allow you to do things like this, right? So if we go to like reference, P5 reference, right? And we look at math, right? So what are some of the math functions that are available to us? You'll find things like power and square root and logarithm and so on and so forth. And here's the rounding, right? So rounding calculates the integer closest to a number. And so closest will be, if it's 0.5, it's going to go up. If it's below 0.5, it's going to go down, right? So we don't actually need this. We need to say, like, regardless of what that fraction is, even if the fraction is 001, we always need to cut it and just take the lowest integer, right? So for that, we have ceiling. This is the function ceiling. It calculates the closest integer value that is greater or equal, greater than or equal to number. Oh, I'm sorry, not ceiling. Ceiling will go up. We need floor. My bad. So ceiling will go up. So if it's 8.8, it will round it off to 9. If it's 8.1, it will round it off to 9. We want to say if it's 8.1, round it off to 8. If it's 8.9, round it off to 8. Doesn't matter. All I want is the lowest number. So this is the floor, not the ceiling. Kind of makes sense, right? Ceiling is above, floor is below. Calculates the closest integer value that is less than or equal to the value of the number. Perfect. So we need to take, and you can sort of like look at how exactly to express it, but it's just like take the number, put it inside the function, and it will give it to you, right? So if I take the floor of this number, boop, something like this, right? So let's look at what we have in here. We have 8, and now all of those circles have been cut off. Well, that's great. That's a good start, right? And I want to do the same thing for the number of rows, but obviously, so okay, cool, run it. But obviously, there's like an issue that the space is now not evenly distributed, right? Everything is kind of clumped together instead of being evenly distributed. So what we want to do is we want to say like, all right, so then we calculated how many circles I'm gonna have. but now I need to make sure that that space is evenly distributed and the circle is populated in within as much space as available per circle, right? So we need to basically take this 0.8 of a column and distribute it between the existing 8 columns, making each one of them by 10% larger, basically, right? So, okay, how do we express this arithmetically? Um, Again, different ways of doing things, but we can kind of sort of calculate what should be the horizontal distance between our circles, right? And so the distance doesn't change. The distance should still remain that fractional number, right? So I'm going to introduce another variable. I'm going to call it, let's call it circle h distance, right? So the horizontal distance between the circles. So if the circle was 100 pixels, right? Before in the previous case, right? When the diameter was 80, the distance between the circles was 100 pixels. I guess no, it's not going to work. So we have now a little bit more space. If let's say if diameter was 100, we would have oh yeah, no, that's right. We had 100 pixels, so we can have the same amount of space. We still have 8 circles. So now we have the same amount of space, but each one of them is going to be a little bit larger, right? So the distance is still going to be width divided by diameter, right? So it is going to be that fractional number. Yeah. So, sorry, not by divided by diameter. We need to now divide it by the number of columns. My bad. Columns, right? So, if the number of columns is 8, we're gonna divide our canvas by 80, right? So 800 divided by 8, we're gonna have 100 pixels, and now the circle with the diameter of 90 pixels is going to be fit into a space of 100 pixels. I know I'm kind of being a little bit convoluted with it. Just bear with me. Let's go over this again. So we figured out the number of columns we need to have, right? So that's our number of columns. Then we need to figure out how to distribute the space evenly, right? And so in order to figure out how much space we have within each column, we just need to divide each one of those columns, divide the entire width by the number of columns, right? So if we have 8 columns, 800 divided by 8, we have 100 pixels. And even though our circles are 90 pixels in diameter, we are going to have 100 pixels to dedicate to each one of the columns. Hopefully that makes sense, right? And so it might kind of like be handy to start adding those console log messages for yourself, right? So for example, let's take this one and put it here, and then I'm actually going to embellish it a little bit. I'm going to start adding some additional information in my console log messages just to make things very clear. So I'm going to add 2 quotation marks in order to start a string and say number of columns, right? And then column space, and then plus whatever that number is that we've calculated. And then here I'm going to say console.log, and then distance, and then not just distance, horizontal distance. Horizontal distance between circles. Circles, again, column space, and then plus circle h dist, right? So if I run it like that, we do have number of columns 8, and then the horizontal distance between the circles is going to be 100, right? And it's going to be between the center of one circle to the center of the next circle, right? Because we're always going from center to center to center. All right, that's cool. Now we need to actually implement this, because obviously you're not seeing any effect on it because the way we're drawing the circle hasn't changed, right? But the point is that we no longer need to use this x times diameter. We're not calculating its position based on the diameter. We're going to be calculating its position based on the horizontal distances between the circles. So in order for us to sort of accommodate this, we're going to introduce yet another variable. And variables, you can start thinking about them as sort of like those handy little containers where we can put results of some small calculations in the interim. And for it's if you notice, it's not even so much for the code to run correctly. We could just cram everything, all the calculations inside the circle function itself, right? It would still work, but it's primarily to make it easier for us, for the humans, to read the code, right? So here I have the number of columns calculated. Here I have the distances between the circles calculated. And then for each one of the columns, now I'm going to introduce a new variable that's going to say, that's going to basically say the x position of my circle, right? So let's call it circle position x. And that's going to be something similar to this this number. So I'm going to cut that out, paste this in here, but I'm going to change it a little bit. And so instead of using the diameter to calculate that position, I'm going to be using the horizontal distance, right? So I'm going to say circle h distance, and then circle h distance. Okay, so now all of my circles are going to be calculated in, or are going to be placed in circle position x, something like that, right? So let's run this. Okay, so now they're evenly distributed, and I can do the same thing for the calculations of my vertical distances, right? So this is my horizontal distances. Let's add a space, and then let's do the same thing over here, right? So I'm gonna add maybe again the console logs. So console.log, and in here it's going to be number of rows, right? Plus number of rows, that's how many rows we're going to have. And then let circle v distance, right? So the v, same idea, but instead of horizontal, it's going to be vertical. So this time it's going to be height divided by the number of rows, and then console.log, and then I don't know why I have it number, should be number, and then let's do number of, oh no, it's going to be vertical distance between circles, like that, plus circle v dist, right? Perfect. So if I run it like this, one thing that's going to remain is for us to properly calculate the y position of the circle. And we would have to do it for every row, right? Because it's going to change. So we have to do it inside that internal for loop. So we're going to, just like this, has to be calculated for every column, because the x position is going to change from column to column to column. The y position is going to change from row to row to row, so we're going to have to do it inside the for loop. So let's do let circle position y equal to, and again, we're taking this number that we've already used because we know that it's very much related to that number, but instead of diameter, we're going to be using this circle v distance. So let's place it here. Let's place that here, and then we can use circle position y. Okay, so keeping fingers crossed, it's all gonna work. Maybe not. If not, we'll figure it out. But yay! Okay, so what that means is that now I can evenly distribute all of my patterns within my space, right? So we have number of columns 8, horizontal distance between the circles 100, number of rows 6, horizontal distance between the circles again 100. We're gonna print this out several times, like however many rows we have within a column, right? Because however many columns we have on in our sketch, because it runs this code, this console log runs for every column because it's inside the for loop. So kind of start paying attention to little things like this, so it doesn't surprise you. Why the hell do we have so many logs of the number of rows and the vertical distances between them? But the interesting thing is now we can start experimenting with like really weird numbers for the diameters, like 87, right? Is it going to work? It kind of still works, right? So we have 9 columns, and the distance, horizontal distance is going to be 88.8, but we have 6 rows, and it's going to be 100, right? So like we can fit more um, uh, horizontally than we can vertically. And we can start playing around with things like 76, right? So what's going to be 76? I don't know. So we have 10 and 7, right? So yeah, so you can start playing around with this type of stuff. I don't mind sticking with 19, right? Just for simplicity's sake. It kind of gave us reasonably round numbers, but without over rounding them. So, okay, so, but that's just the beginning of the conversation. So now that we have the circles, it would be nice to create some kind of like a progression of the circle. And progression in a sense of the color, right? So what I mean by that is that, so let's imagine a situation where I want every next row to be slightly different in color. And what I mean different in color is changing by a little bit, right? So I'm sure you're all familiar with the concept of the color circle, right? Color. Okay, so color.adobe.com has a decent illustration of what that color circle is going to be. Go away, all of those little pop-ups, right? But then like, let's just visit this. So this is our color circle, right? And if I wanted to create like, let's just do a square. If I wanted to create a situation where like I start, let's say at red, right? Usually red is considered to be the starting point, right? And then I want to move towards orange, and then towards yellow, and then towards green, and then towards cyan and blue, and so on, and kind of like go around this color circle and change the color next to the next to the next to the next, right? It will be fairly difficult to do this using the RGB color mode, because as I'm increasing the amount of red, I'm also have to be, or as I'm decreasing the amount of red, moving over towards yellow, right? I also have to start increasing the amount of green, and then at some point start increasing the amount of blue, and it kind of gets very convoluted. And so in order to facilitate those smooth transformations from one color to the next, right? Not just necessarily having a color, but transforming a color. We have a HSB color mode. So it's one of the options. You can select HSB over here. So HSB color mode allows you to encode the color instead of red, green, and blue components in terms of its hue, saturation, and brightness. Hopefully you've already encountered this idea, but if you haven't encountered this idea, you can think of an HSB representation as a cone, right? So if you Google for HSB cone, right, and go to images, so you will find something like this maybe, right? So the idea is that H, hue, represents that circle, right? So it's going to go from red to orange to yellow to green to cyan, blue, and so on and so forth, right? So that's going to be our hue. The saturation is the amount of color, right? So if you have little saturation, you have very little color. If you have a lot of saturation, you have a lot of color, right? And then the value or brightness, depending on which system you're working in. For us, it's HSB. Brightness or HSV value is going to say how much, how bright the color is, how much light there is in the color, right? So let's say if you imagine a situation where the saturation is at 0, it doesn't matter what hue you have, right? You are always going to get the grayscale if you just change one value. Simply changing single value will give you the movement along the grayscale. So brightness will do that for you. If you have saturation at full and value at full, in order to move from one color to the next, you again only have to change one value, which is hue, right? So this is the scale that's particularly well suited for changing color from one to another, right? So we do have the implementation of it in P5.js. So if you look at the reference, let's go back to head of the reference and look at color, right? You start getting hints like things like, oh, hue is listed as an option, or saturation is listed as an option. But fundamentally, in order to implement that, you need to change the color mode. So by default, P5.js starts in RGB color mode, but we can change it from RGB, which is the default, to HSB or even HSL. We're not going to deal with HSL. It's kind of like HSB, but instead of going from 0 on the brightness to 100 on the brightness, or like from 0 brightness to full brightness, it goes from no brightness to full brightness back to no brightness. So it's kind of like, instead of a cone, it's more like a diamond type shape. But HSB, for our intents and purposes, is more than enough. So when you're changing the color mode, if you read through this color model thing, color model page, you will also notice that you will be able to set the upper and lower value of those parameters, right? So it's going to be between 0 and something. So by default, our RGB mode is set between 0 and 255, because this is very, very common. This is how vast majority of systems implement the RGB system, between 0 and 255. We could, if we wanted to, implement it between 0 and 100, right? So that full red, right, would be 100, 0, 0, instead of 255, 0, 0. That's also an option, right? And it can be very, very helpful when implementing the HSB model. So again, going back to our sketch, what I want to do is I want to move along the color wheel from one column to the next, to the next, to the next, so that my first column is red, the next column is orange, the following one is yellow, then I have a green one, then I have a cyan one, and so on, right? So all I have to do is move from one point on the hue, right, on the color circle, from one angle to the next, to the next, to the next, to the next. And typically you would think of a circle, since it's a circle, as having 360 degrees, right? So you would go full rotation in 360 degrees. But here I'm gonna say, well, then if I make it 360 degrees, or my hue values will go between 0 and 360, it's going to be very difficult for me to readjust this and figure out which point is going to be this column, right? So my X value is, at this point, is 45, right? So half of the 90, 0 plus half of the diameter. Oh, and plus a little bit here, right? So it's actually closer to 50. So this is going to be 50, but if I move 50 degrees on the color circle, I'm going to be way outside of the red territory. I'm going to go closer to actually like greenish yellowish point, right? Because it's going to be quite a bit of a jump on the color wheel. I don't want that. So that's what the color mode values are intended to do, right? So you can, instead of setting values between 0 and 255, or setting them between 0 and 100, you can set them between 0 and anything you like, really, right? So if the full spectrum of my hues are going to be encoded as the width of my sketch, that's what I can do. I can say that my color mode, right? So let's do this whole color mode thing. Color mode, we're going to use HSB, and then the first value is going to be the range of values for your hue, then the range of values for your saturation, and then the range of values for your brightness. So we can do something like width for my hue, right? However many pixels I have in the width, stretch the entire spectrum of color through that distance, right? So on one hand, it's going to be red. On the other hand, again, it's going to be red. And we're going to go through the entire rainbow of the colors. If I have 800 pixels, well, it's going to be within 800 pixels. If I have 400 pixels, it's going to be from 0 to 400. If I have 360 pixels, then it's going to be equivalent to 360 degrees on the circle. But most likely, I'm not going to have that, right? So I'm going to have full width to represent my hue, and then let's say 100 and 100 for my saturation and brightness. So 2 things you're going to notice. First of all, background is going to get really weird because 125 now means something completely different, right? We used to set this in grayscale. Now the whole thing is out the window, right? So we're going to see, I'm not going to change anything. And yeah, so let's just run this and see what happens. Okay, so we have like just white color, right? And a bunch of strokes for the images, for the circles. So I don't want that. Let's remove strokes. So no stroke. We can always say that. No stroke for any of the shapes that we are going to be drawing. It's kind of like fill, right? So if you dip the brush and then paint it with a certain color, remember that concept, right? I can also say that like the brush that I'm using to draw the strokes, I'm going to just not have it or disregard it, right? So no stroke, that's one thing. And then let's change the color of a background. So remember how I said that it doesn't really matter what hue you're using if your saturation is at 0, right? So if my hue is 0, right, and my saturation is 100, and then my brightness is 100, well, this is going to be red, right? Because our color starts at red and then goes to yellow to or orange, yellow, green, and so on, right? So this is going to be a red background, very red. So just to prove it, width divided by 2, so half, right? So if you remember the color wheel, right? From red right here to the other side, it's going to be kind of like greenish cyanish color, right? So like if I run it like at this, it's going to get, actually it's very close to cyan, right? So it's going to be that. And then obviously if I'm going to make it full width, it's going to go back to red, right? So that's your whole hue spectrum represented from 0 to width. But if we just want to use grayscale, it doesn't matter. We can put it in anything we like and just decrease the saturation. So this is going to give us white, and then I can decrease the brightness to 50 out of 100, and it's going to give us like nice gray. So maybe I'll decrease it even further, make it like 30, right? Or even 20, just for dramatic effect, right? And here we go. We have very, very dark green or dark gray background. So now we can start coloring our circles, right? So again, that's going to be a fill. So fill. And then for every circle, the hue component is going to be defined as its position in the horizontal space, right? So what I can do, I can just use the circle position X to set its hue, right? Because I'm going to have red over here. I'm going to have cyan somewhere over here. I'm going to be back to red over here. And so it's going to be red, orange, yellow, green, cyan, blue, purple, back to red, right? And then in terms of saturation and brightness, I can do something a little bit milder, maybe like 80% for both, right? So it's not too bright, not too saturated. And then if I run it like this, I have a nice distribution of color, right? So this is where the um, color mode is super, super helpful, right? If you just want to change one single value, if you wanted to change the saturation with its vertical position, you could do something similar where your height will now determine saturation, and then your circle position Y would give you how saturated the colors are. Not super happy with it aesthetically, so let's just undo this, and I'm just gonna go back to 80. But I just wanted to sort of illustrate the point. Yeah. All right. Fantastic. So let's progress from here a little bit. Hopefully this is kind of getting you somewhere. Now, next order of business. What if I wanted to now remain with the same amount of space that I've allocated for my circles initially, but I want to increase them and have them overlap, right? So this is kind of like my initial point, and then imagine them just growing a little bit. So the diameter of my circle, instead of being 90, I'm going to make it some arbitrary number for now. Like let's say 150, right? So I calculated the space based on one diameter, but then I started drawing circles of a different diameter, and then I'm going to have overlapping, interacting circles. Something like this, right? So right now, if you remember, we said that every next shape is going to be drawn on top of the previous one. So clearly, the first column is drawn first, then the second, then the third, then the fourth, and so on. And then to be in keeping with our index numbers, so this is going to be column number 0, column number 1, column number 2, column number 3, column number 4, and so on. This is cool, but this could be a little bit more interesting if we start introducing another concept, transparency, right? P5.js is fully capable of transparency. And so we can, just like setting up the numbers for the H, S, and B parameters, hue, saturation, and brightness, you can also add the colors for, where's the example? Well, here is a good example. So you give it the mode, you give it the maximum amount for 1, maximum amount for 2, maximum amount for 3, right? So if it's HSB, it's going to be maximum H, maximum S, maximum B, and then optionally maximum A. So a range for your alpha channel or your transparency channel, right? So let's add our transparency channel, and let's have it at 100 also, right? And then for the circles, I'm going to add the transparency value of 30. So 30% transparency. Okay. So we have those circles now blending and creating a certain pattern, right? You will notice that some of the interactions are not exactly even. Like this is much brighter than this, for example, right? And so but we are creating a very specific pattern in the canvas, and it's kind of nice. So now the next question to ask would be, how do we determine the color of each and every one of the pixels, right? So we have gray background on top of, like, for example, right here. So first we drew the gray background. Then we drew one red circle. Then we drew another red circle. Then on top of that, we moved on to the next column and we drew a yellow circle and we drew another yellow circle, right? So we have quite a few values overlapping here. And so how do we determine what's the value of what the actual color on the screen that shows up? And so this is determined by the algorithm called blending mode. So or blend mode, right? So if you go again to the reference, and let's just search for it, blend mode. It's going to be in the rendering section. Right, so it sets the way the colors blend when added to the canvas, right? So the by default, the drawing with the solid color paints over the current pixel values on the canvas, right? We have other options for blending colors, and they're like all of them are listed here. So add, blend, darkest, lightest, exclusion, difference, multiply, screen, and so on. There's like a huge list of it, right? And so we could select a different blend mode and have a different result show up on the screen. So if you scroll all the way down here through all of those blend modes, you can see this whole list of modes, and some of them are only available in 2D, right? So I have them all set up and prepared. So let's just pick one of them. Let's do exclusion. I don't know why, just because, right? So let's implement one, and then I'll show you how we can make the testing and trying different blend modes a little bit easier, right? So what we're gonna do is blend modes are only going to be available after you create the canvas, kind of like the width, right? It's also one of those things that is created as a part of the canvas. So we can set the blend mode maybe somewhere after the color mode, right? To just keep things logical, right? So we're going to do blend mode, and then I copied and pasted exclusion. So notice that the word, it goes without the quotation marks. It's just the word exclusion. That word points to a number. I think it's number like 7 or 6 or something, right? Or whatever, right? But it's kind of like a previously defined global level variable that you can reuse and you cannot overwrite. Okay, so if we use blend mode exclusion and run it like this, we're going to see a different pattern, right? We have different blending results. It kind of got a little bit darker and sort of like more subdued, right? So you could potentially try and copy and paste all of them, right? So like go to darkest, paste this in here, try this. Whoa, obviously the gray is going to take over because that's the darkest. Or you can do like hard light and keep trying and keep trying, and it's going to be pretty tedious. It's going to get very tedious very soon. So what you can do, you can create an array of all the blend modes, and this is where we start introducing this idea of an array. And so an array is just a collection. It's a collection of things, right? So we have however many blend modes we have. We can count them. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 blend modes. Fantastic. So that means that we have a collection of 16 elements, right? And we can create an array. Let's make an array right before the blend modes. Let's say let blend modes equal to, and so here's how you create an array. There are several ways of doing this, but the simplest one would be to open the square brackets, and in between the square brackets, start pasting in the members of the array. So the first one would be blend, like this, right? And then all the arrays, I think I already mentioned that, all the arrays starts at 0. So this is, even though we call it the first member, it's actually going to be member index 0, right? So comma, and then the next one, right, which is going to be darkest. But if you notice, they already have them listed separated by commas, so that makes it very easy for you to just take this and just put this inside your array. And I like to sort of separate my array members, especially in an array like this. I like to separate them, each one on its own separate line. So I'm gonna do, whoops, multiply, right? So you can do something like this, or you can then just take the array from the code that's included in the video and copy and paste it from there. So or is not a thing, so we need to add a comma in here. But then we have an array of 16 members, right? So from 0 to 15. So some of them are only available in 2D mode. I believe starting from like difference and onward, they have it. They have that in the description. If you go back up here, difference, overlay, hard light, soft light, dodge, and burn are only available in 2D mode, which is fine for us because we're only working in 2D mode. We're not dealing with 3D. But now, instead of just copying and pasting that term into your blend mode, you can just simply call out the member of the array by its index. So if I want to use blend, right, I'm going to say, give me the array blend modes, let's spell it correctly, and then call up index number 0. So index number 0 is going to give me mode blend. Index number 1 or number 2 is going to give me lightest. Index number 3 is going to give me difference, right? And so on and so forth, right? So each one of them is going to be slightly different, and you will notice that, and you can start experimenting with them and so on and so forth, right? But yeah, that's the general idea. So this is how you can think about distributing space alternatively, and how you can start thinking about color modes, and blend modes if you're using transparency. So hope you create something interesting with this, and I will see you next time. Have fun with it.